So now that you know how to check to see if two things are similar, we're going to talk about how to actually solve problems using what we know about similar figures. Okay, so for example number 4, notice they're telling you that these two figures are similar, and then they ask you to actually find x and y. Okay, so first of all, remember when two things are similar, there's two things that are true. All of the matching angles are exactly the same measure. And then if you take their sides and put them in fractions, they'll actually be equal to the other sides when you put them in fractions. Okay, so if I'm trying to find x and y, I'm going to start by looking for where x and where y is. So I have an x right here. And if I go ahead and look at which side this matches up with, if I look here, ST matches up with NO. So I know that if I put those in a fraction, it'll equal the other sides put as fractions. So that might be useful here. And then my y is right here. So I'm going to go ahead and look at which side this matches up with. So let's see. SR is that side. So SR is like in the middle here. So then MN is over here. So it's going to match up with that one. Okay. So I will have to use that to be able to solve this problem. Okay. So now, how do I actually set this up to solve? Well, you're going to have to use proportions. And so remember, proportions are where you take the sides and put them in fractions, okay? You're going to have to do these one at a time, though. So like, for instance, if I was trying to find x, well, I could take x and put it over its corresponding side. So not like, notice, x corresponds with 2. So I could take that over 2. But then I have to set it equal to another fraction so that I can find x. If I set it equal to like the y over 3.2, that's not going to really do much for me because I won't be able to solve for this. So what I'm going to have to do is look at other parts of my figures and see if there's another fraction I can set it equal to where I can actually solve it like I do regular proportions. So if you look, in this figure, which is the one I started with, so make sure you're consistent since I started with this figure. If I look, I have a 6 in there. And so notice that actually corresponds with that one. So if I can put that in a fraction, I would know that they're equal, okay, because the sides are proportional. So what I'm going to do is I'm going to use this and its corresponding side, and that'll actually help me a lot. So this would actually be equal to 6 over 5. And notice I have like a little equation set up here and I can actually solve for x. So how do you solve this? Well, if you remember, when you have a fraction equal to a fraction, you do cross multiplication. So you're going to take the x times the 5, so you get 5x, and then you put your equals, and then you do the other cross part. So then you take the 2 times the 6, or the 6 times 2. 6 times 2. And then you just simplify. So we've got 5x equals 6 times 2 is 12. And then all you have to do is divide both sides by 5. So you take 12 divided by 5, and you get 2.4. So x is equal to 2.4. So that is the length of that side. Okay, so that's x. So x is equal to 2.4. So now how do you find y? Well, you could actually do something very similar here because this, remember, is showing how they compare. So you could actually use this same setup, but you can set it up with y now. So I'm going to take y and put it over its corresponding side. So it would be y over 3.2. And then that would be equal. I can set up, because this is still how it relates to the other one, so you could still equal that to 6 over 5. Okay, then you cross multiply. So it'd be the y times the 5, which is 5y. And then you take the 6 times that 3.2, so 6 times 3.2, we get 19.2. And then from there, you just have to divide by 5. So 19.2 divided by 5, we get 3.84. So y would have a length of 3.84. And so notice sometimes these sides don't work out real pretty, but There you go. Okay, so whenever that you're told that they're similar and you have to find the lengths of sides, just remember that you could set them in fractions and set them equal to other sides that kind of match up with each other. All right, so let's do a couple other problems. So number 5, it's saying that we've got triangle RST and it's similar to triangle XYZ. And you have to find X and Y, okay? So find your X and your Y. So let's see, we've got our X right there. And so this right here is like the length of that side. And then we've got the Y, and that's an angle. So we're going to have to use what we know about our angles, okay? So let's start with X. So I know that if I take this and I put it over its corresponding side, it'll be equal to, like for instance, this over its corresponding side. So that's what I'm going to do. So I got to figure out which one RS corresponds with, though, because this one has been kind of turned around and all that good stuff. So, okay, look at your similarity statement. RS is the first 2 letters here. So then the first 2 letters will match up with it. So XY is its matching side. So this side will match up with that one. So that's the one I'm going to put it over. So it'd be X plus 4, and I put it over 10. Okay, and that would be equal to any other side in this one over its corresponding side. So notice I'm given a 3 here, so figure out which side that this matches up with. So that one deals with the side ST, so ST's right there. So then the side that matches up with it is YZ, which would be this one. So I take the 3 and I put it over that 6 right there. Okay, so from there, just like you did the other one, you got to cross multiply. The only thing here is there's 2 terms here. So you've got to put that in parentheses, because when you cross multiply, that's going to remind you that you have to distribute. Okay, so when I cross multiply, it's going to be 6 times X plus 4. And then on the other side, we've got 10 times 3. So 10 times 3, okay? So the reason you have to put your parentheses is because that reminds you to distribute. So you take 6 times X, 6 times 4, so you get 6X plus 6 times 4 is 24. And then on the other side, 10 times 3 is 30. From there, you have to subtract your 24, so you got to start solving. So these go away. We're left with 6X equals 6. Then you divide by your 6. And X is equal to 1. So X is equal to 1. So now if they asked you for the length of this side, what you would do is you'd take that 1 and you plug it back in for X. So it'd be 1 plus 4. So the length of that side would be 5. Okay, so if they actually asked you for the length, you just take that and plug it back in for X. Okay, so now how do we find Y? Well, it's an angle, so find the angle that matches up with it, because remember, with similar figures, the angles that match up are actually congruent. So which angle matches up with angle T, essentially? Well, notice Z is in the same spot, so Z has a measure of 20, so then guess what T is? Same thing. So Y was pretty easy. It's 20 degrees, okay? So there we go. So if you're asked for an angle, you know that the matching angles are actually equal, okay? So the last one, if they give you something like this, I just wanted to just kind of show you a trick with this. So if they give you something like this and they ask you for X, do you see how there's like a little triangle that's almost been laid on top of a bigger triangle? When they do that, you actually want to separate your triangles. So I'm going to take that little triangle off. And so I'm going to just label it. So the bottom part is 3, and then the side of it is X. Okay, so that's my little triangle. And then you copy down the big triangle and label it. So the big triangle, so look at your big triangle, the bottom side is 12. And then now that little X goes with the little triangle. Look at the big side. So this entire side is 8. So that would be 8. And notice that actually makes this way easier to set up. These two triangles are similar. The reason for that is because this angle is equal to that angle. So like these two angles would be the same. And then also they share this top angle. So these two angles would be the same. And something that you haven't quite learned yet is when they have two angles the same, that makes the third angle the same. and that would mean that they're similar, okay? So because they're similar, you can set up the sides as a fraction and then find x. So we'd put x over its corresponding side, so it'd be x over 8 equals, and then you take, well, 3 would correspond to 12. So notice we've taken the things that are in this triangle and we put them on top, and then the sides from the other triangle go on the bottom, and then we just cross multiply. So x times 12 is 12x, and then 8 times 3 is 24. And then from there, divide by 12, and x would equal 2. So the length of this side would be 2. Okay, so that's how you solve problems using what you know about similar figures.